In this video, we're going to be talking about how to solve for acceleration and constant velocity. So, what is constant velocity? It is an object that must have a constant speed and a constant direction, and the ratio of change in velocity and change in time. Also, the slope should be the same for all the vectors. Again, the slope could be defined as a rise over run. So, this image that I have here, it's constant velocity because it remains at 200 centimeters per second for zero point 0.4 seconds, or at least it seems to remain at 200 centimeters per second for an infinite amount of seconds. What is constant acceleration? Constant acceleration is a change in velocity over change in time, and an object changing its velocity by the same amount each second. So as you can see in this problem, there's a line, a diagonal line that is leaning towards the positive side, and it appears to be moving constant because there is no change in any vectors, there's no resting point or decreasing point. So the kind of problem that I picked out was from WebAssign 01A, and this problem relates to constant acceleration, and it could potentially also relate to constant velocity. So in this scenario, it says a child operates a remote-controlled toy car on a linear track. The figure below plots the car's position as a function of time. So what we're going to do this problem is first we're going to solve for the acceleration. And to do so, we're going to split this problem into 4 parts. So first off, we're going to try to solve the acceleration from 0 to 2 seconds, 2 to 4, 4 to 6, and 6 to 9 seconds. And again, the change in the formula to solve for acceleration is the change in velocity over the change in time, and that gives us the acceleration. So let's get started with number 1. So again, we're solving for the acceleration from 0 to 2 seconds. We're primarily focusing on this line. So, again, change in velocity over change in time. So to make it easier, we're going to substitute the x by a v to stand for velocity. So we're at 3 seconds between 3 meters and 0. So we're going to do 3 meters minus 0 meters over 2 seconds minus 0 seconds, because we're at 2 and we start at 0. So we're going to divide 3 by 2. That equals 1.5 meters per second equals the acceleration. So that's the acceleration for number 1. Now moving on, we're going to try to solve the acceleration between 2 seconds and 4 seconds. So we're focusing on this part of the problem. Okay, so change in velocity over change in time. Our velocity here is 3 meters minus 0.5 meters over 4 seconds minus 2 seconds, giving us 3.5 meters over 2 seconds. We divide that. We get 1.75 meters per second as our acceleration for the second portion of this problem. Now moving on to the third portion of the problem, we're trying to solve the acceleration between 4 seconds and 6 seconds, which is here. Here, automatically, visually, at least in my perspective, I can automatically say that the acceleration in this portion of the problem is going to be 0, just because the line is flat. There's no acceleration or no changes happening. It's just a straight line. So I'm assuming that the acceleration is 0 meters per second. However, we're teaching you how to solve it, so let's solve it. Change in velocity over change in time. So the velocity isn't changing. So it is negative 0.5 minus negative 0.5 over 6 seconds minus 4 seconds equals 0 over 2 seconds. And again, anything over 0, anything or zeros over, it will equal 0 meters per second. So 0 divided by 2 equals 0 meters per second. That is our acceleration for this problem. And the last problem, we're going to be focusing on the acceleration between 6 seconds and 9 seconds, which is here. Alright, so again, change in velocity over change in time. Here the change in velocity is 0 meters minus negative 0.5 meters over 9 seconds minus 6 seconds. So this gives us 0.5 meters over 3 seconds. If we divide that, we get 0.17 meters per second. And that is our acceleration for this problem. So for the velocity portion of this well-assigned problem, we're going to be using the same format. We're going to be solving the velocity in 4 different parts between 0 to 2 seconds, 2 to 4, 4 to 6, and 6 to 9. The velocity could also be seen as a rise over run, as you can remember algebraically. Or in other words, it could also be referred to as meters per second. So let's get started. So what's the velocity from 0 seconds to 2 seconds? So we're solving for this line. You can see it rises 3 meters and then it runs 2 seconds. So 3 meters divided by 2 seconds gives you 1.5 meters per second. That is our velocity. Velocity from 2 to 4 seconds, as you can see, it rises 3.5 meters and it runs negative 2 seconds. So 3.5 meters divided by negative 2 seconds, that gives you about minus negative 1.75 meters per second as our velocity for this problem. For the third portion of the problem, it's between 4 to 6 seconds. Again, visually, you're safe to assume that the acceleration and velocity in these horizontally straight lines are going to be 0, because there's no acceleration, there's no decreasing or slowing down or any movement. It's just a flat horizontal line. However, I'm teaching you how to solve for velocity, so we're going to solve it. So as you can see, it doesn't rise anything, so you could say 0 meters. And then it's up to you whether you decide to run -2 or positive. So it doesn't really matter, because when 0 is over any number, in this case let's say 2 seconds, it will equal 0 meters per second, regardless if it's a negative number or a positive number. That is our velocity from 4 seconds to 6. And for number 4, between 6 seconds and 9 seconds, you can see the line's increasing. It's probably going to be a positive velocity. So in this problem, it rises 0.5 meters and then it runs 3 seconds to the right. This gives us approximately 0.17 meters per second as our